All right, so we learned last section the derivative at a function at a specific point A is this. So this is using the definition with h. So now I want a formula for the derivative. So instead of putting a in, I'm going to leave it as x, right? Instead of putting a in, I'm leaving it as x. So then I'm ready to put in any value for x. Here we go. So let's find a formula for the derivative. This is the equation using this definition. So f prime of x will be the limit as h goes to 0. So let's just go do it, yes? F of x plus h means put x plus h everywhere there's an x. So x plus h squared plus 4. So that's the first term. Subtract, right? Subtract f of x. So f of x being x squared plus 4 all over h. So let's take and multiply this out. And then to make sure we distribute the negative sign. All right, what cancels? My 4's are gone. My x squareds are gone. Let's see what I have left over. 2xh plus h squared all over h. So you know the best thing to do is to take the time to factor the h out. So then those cancel. So now it's my job to plug in h equals 0. So if I plug in h equals 0, I get 2x. So what that means is the derivative formula is 2x. So let's just go and graph this. So what is the graph of f of x? Parabola shifted up 4 looks like this. So that's f of x. So what is the graph of f prime of x? Line, slope 2. Okay, let's just kind of investigate here. What does the slope of that tangent line right there look like? If I drew a tangent line at x equals 0, it looks like the slope is 0. So this is the derivative. So at x equals 0, the slope is 0. So if I was to look at this point like 1 here, draw a tangent line, because we have to draw a tangent line at a specific value, right? Looks like it's a positive slope. If I put this point 1 in right there, that y value would be 2. Does that green line look like it has a slope of 2? I do believe it does. All right, let's just try one more. So if I was to pick a point like -1 and draw a tangent line, negative slope, -1, the y value on this line would be -2. Does this tangent line, this black tangent line, look like it has a slope of -2? So I want you to start to think about reading this y-axis that's labeled as f prime as slope. All right, let's go through and do this next example here. So use the definition of the derivative, and there's the definition of the derivative. We've just found that it's easier to do with the definition with h. So let me just write it down here again, and then we'll plug it in. We're keeping x there. So limit as h goes to 0. So 1 over x plus h minus 1 over x all over h. We've seen these before. We want to multiply by the least common denominator, which would be x times x plus h. So here we go. Limit as h goes to 0. Distributing, canceling as I go. Distributing, canceling as I go. xh, x plus h. All right, limit as h goes to 0. X minus h. So I just get a negative h on the top. So I can see I can cancel the h's. So let's write my simplified version here. -1 x plus h. All right, I'm ready to go. I can plug in h equals 0, plug in h equals 0, and I get this. So the derivative graph is negative 1 over x squared. So the g of x is 1 over x. We know that looks like this, right? G prime of x is negative 1 over x squared, which we know is if flip over the x-axis looks like this, right? So this is g prime, this is g. So again, we're going to be investigating things like this. So let's just look at this for a second. So this line right here, if I was to draw a tangent line at that point right there, that looks like some negative number, right? If I was to find the slope of the tangent line, the y value that's associated with that point right there, that's a negative number. If I was to make a tangent line right here, that's a small negative number, negative slope. And if I was to pick that same point over here, that's a small negative number. And look at x equals 0. I can't draw a tangent line at x equals 0, right? There's nothing that exists here at x equals 0 on the function. Oh, there's nothing that exists here at x equals 0 on the derivative. So there's big correlations.